Hello, this is Questionable Coding with Vladimir, and today we're going to cover a stack data structure, which is pretty well known and quite easy. So we'll go through real-world examples of stack-like behavior, and we'll implement it in JavaScript in at least two ways. Also, we'll cover main methods of stack and the algorithmic complexity of those methods. Stack is a linear data structure which consists of nodes. Currently we have 4 nodes as an example, and it represents a very specific order of processing those nodes, which is called LIFO, or last in, first out. Every time we deal with stack, we deal with the latest element or the top element. So we usually have a top pointer which points on the latest element, and every operation is done for this element. Also, every node or element is pointing to the node underneath it. Let's see when we face stack-like behavior in the real world. The most famous example is a pile of plates, and when we take a plate, we take it from top. When we put a plate back, we also place it on top, because it doesn't make sense to take a plate from the bottom or place it to the bottom, because they are pretty heavy and there is no difference about the order. We don't want any specific plate, we just want a plate. It doesn't have an expiration date or something, so we're satisfied with the closest plate that we have, and that's one on top. And another example is a metro train. So when people enter a train or any transport, usually those who enter it the first will be the last one to leave, because the last person who enters the train will be closer to the door. So when we have such a situation, when we have like one exit and some container, then the first things that enter the container will leave it the last. So it's also a stack-like structure or behavior. And the last one, I think it's also very nice example. It's about a holder for basketball balls or any balls, and we also, if we want to take a ball and play, we'll take it from top, because it's constructed like that. And if we want to place a ball back, we also place it on top. So what are the stack operations that we usually use? It's definitely push and pop, so it's insertion and deletion. But sometimes we can have additional methods like pick, which returns the top element and doesn't delete it, or empty, which tells that the stack is empty and doesn't have any elements. We can also have additional methods if we need to, because sometimes it's easier to track the minimum element or the maximum element in the stack. And if you have a task that just forces you to use that, then feel free to add it, but by default you don't need it. Let's start with push. So we have a stack with 2 nodes, and the pointer is pointing to the node number 1. And now we add a new node, and it goes on top, and the pointer will be moved to the latest one. And once again, if we add another one, it will be added on top, and top will move to the third one. So pop is the inverse thing. So we just take an element from the top, and the pointer goes to the element underneath it. And once again, we just pop this element, and we move the pointer. Pretty easy. Okay, so what is the complexity of those operations? What about insertion? In fact, we have a stack, and we just need to apply a new element on top and make it point to the previous tab and move a pointer. So basically it's like 3 operations, but regarding algorithmic complexity, it's big O of 1, which is perfect. Deletion is the same. We basically remove the element and remove the pointer. So it's also, it doesn't depend on number of elements on the stack. But everything is not that good with search. The complexity of search is linear, so if we want to find something, some node with some data, we need to go, in the worst case, we need to go through every element we have by popping it or with some other way of doing that? Yeah, probably it will be pop and just returning them back. So it's not a data structure for an easy search. That's what we need to remember. Now we're going to implement stack in JavaScript in two ways. The first one will be very similar to what we covered when we use node, which points to another node. We have a tab pointer and so on. So we're not using JavaScript built-in arrays, and we'll do it like from scratch. For that, we'll have to create a function called node. So it will be class node. We'll use classes for that, but it doesn't matter much. Class node with a constructor which accepts data. It will just wraps the data, and it will be this data equals data, and this next will be null. It will be a pointer to the next element. Another class will be the stack itself, class stack. For this, we need also a constructor. In constructor, we'll have this tab pointer pointing to null when we just create the stack. And we have two methods. First method will be push. So what we should do here, we pass some data. User of this class will pass some data, and we need to first create a node for that. So it will be const node equals new node, and we're passing the data here. Then we need this data to point to the top element of the stack. This node next will point this tab, and if the tab is null, then we're okay with this. So that's what we want. We can return something, but let's just keep it super simple. We can return the node or data, probably the data, and we have a pop method. Oh, sorry, we didn't move the pointer, so we need to move the pointer itself. So the tab will point to the node we added. So this one will change. You remember in the animation we moved the pointer up, so that's what is going on here. And the pop. So pop doesn't accept any argument. It will return data of the node we popped. And at first we need to test if there is no tab, or if this tab equals null, then we'll return null. Otherwise, we'll save this value we want to remove, node to remove, and it will be something that on tab right now. And we want to move the tab to the next element, and it will be this tab equals node to remove next, something that lies underneath this node to remove. And then we just return this node to remove data, so the user can have it. And we are doing two things at a time, removing this element by moving a tab pointer down and returning the data. Okay, so we have two methods and we can try to execute them. Let's create a stack. Create a stack, new stack, and let's push some elements. Let's console log it first. Stack, and then let's push some elements. We're using stack push. Let's push a couple of them, like 1, 2. 1, 2, 3. And once again, we will console log. Okay, let's run it. And yeah, initially it's the top null, and then tab points to the node which has values 3, and it also points to the node which has the value 2, and it points to the next node, and it's not shown here because that's how it's usually showed, not the entire depth. Okay, then let's pop a few values. Stack pop. 1, 2, and let's go with 2. And also console log the stack. So what we expect is we expect one node left with data equals 1. And yeah, that's what we have, data 1, and next is null. Let's pop it a few times more. So this one will just remove the last element, and this one will pop null. And we'll also console log stack. Yeah, and in the end we have only null. Also, I want to check if the pop returns the proper value. So this one should return value 2, because that's the second element we remove. Let's console log it, and I expect it to, yeah, we have 2 here. And yeah, that's it with basic methods. What if we want to implement pick method? Let's do it. It's very straightforward. So pick method will return the top element without removing it. For this we can copy this pop method but not move anything. And this one will be this top data. That's all. For pick, let's do it after the second push, for example. And what we expect here is data 2, number 2. Now we have an error because I didn't use the variable itself. Yeah, so pick equals 2 works pretty good. And the last thing we want to implement optionally is empty, which will check if the stack is empty. So we just need to return this comparison, this top equals null. And that's all. Let's console log it also. Let's do it in the end. And it should be, once again, stack, because we call it the method of a specific object. So it's true, and if we move it a little bit up when it's not yet empty, it will be false, and then it will be true. Perfect. That's how we can implement it without using built-in array method in JavaScript. The last thing we're going to do is implement the same thing but using built-in array, which is much easier because everything is implemented there already. We will leave the class structure, but you can just use an array without using specific methods, class itself. You can just perceive one array as a stack, call it as a stack, the variable I mean. What we don't need here is the node class, so we'll just deal with an array. In constructor, we don't follow a pointer, we'll have it just an empty array here. And how push will differ? It will just use this array push, and push data. Pop is also super easy. It will be return this array pop. So method is already built in array. And pick will be also very simple. We'll return this array, and we need to select the last element, which will be this array length -1 because of 0-based index. And is empty will also be super easy. We'll compare this array length to null, not to 0, sorry, to 0. So what we'll change here is, I think should be changed. Let's just try it. I'm just using everything we did in the previous lesson. And yeah, we have first we have an empty array, then we push 1 and we push 2, and we have an array of, we have pick, which is 2. It's when we just look at the latest value, and then we push 3 and we console log, and we have all 3 elements. We pop one element, it's 3, then we once again pop and console log the second element, which is 2. Yeah, so basically it's the same test. We can switch back and just rerun it, and here we'll have the same thing. Yeah, so both options are working, and of course it's much easier to do it with built-in array, but it depends on your purpose. If you want to re-implement it from scratch, then you need to use a pointer, nodes, and so on. If not, then just use an array in production code. And that's it. Please subscribe, stay tuned, we'll cover more data structures later.